Alright, we're just going to finish off this project on a very messy desk. It's going to be quite a disorganized video. But anyway, I did get it to work. There were a few issues. I'm in fact going to take this out for a second, and we'll come back to. I'm going to show the issue. So I can't actually remember now that I started this video what the fault was. I think it was something to do with the clock. Oh, that's one thing I did is I made the same mistake again. It must be the way I read these books. But the clock enable, it has to be, what does it say here? It says here, the clock enable for normal operation should be ground, at ground. I think the thing is, in the other book it says clock. I always think the clock enable has to be high or something like this, and I'm always making the same mistake. So what was happening last time is that the clock wasn't actually moving along. But I fixed all that, but there's going to be a little problem. So I'm going to turn this on now, and you can see that these ones come on. So I've actually gone and plugged in my make-believe, don't need this one here, my make-believe Megadrive controller, because the only Megadrive controller I have that I can find, I don't know where the other one is, but it's this one here, and this is the one that I broke. So we can actually see what happens when you plug this in and what it comes up with, a bit better than with this style one, because this one just gives a single number, and you can actually see there's a bit more going on when you use the LEDs. But it does kind of, like if I push the buttons, these different LEDs come on, but some of them don't work. So the first two, it's a bit hard to see here, the first two are going to be, because I haven't wired these ones up and down, so this is up and down here, and they don't do anything except these kind of react. But they're not actually reacting in any meaningful way. You can see it's kind of flashing. So one thing I should point out here is that the green LED is actually linked up to the NOR gate. So it's very hard to tell because it's very dim. The little pink light, I don't know, it is coming across, but that one's actually flashing at about 1/4 of the rate of the NOR gate, which is what it should be doing. If I can just dig up this little picture here, because basically here's the clock pulse, and the NOR gate output is what's going into select. So you can see here you go up that's one cycle, 2 cycles. How does this house work? Okay, 1 cycle to get to there, 1 cycle to get to there, and that's the select being low. 1 cycle to get to there, 1 cycle to get to there. So there's 2 cycles when it's high, 2 cycles when it's low, so it's 1, which is what we want. So this is working, so we know that the select output is going fine. And most of them do work. It's a little bit sluggish when you use it because this is going quite slow. So basically it's not really going to register anything if you do it faster than the flashes. And if you hold it on and you let go, there's like this little delay when they go off. But there's these two troublesome LEDs here, and they're actually linked up. They're actually linked up to pin number 9. They're related to here, so they're the start and button C. So the start button doesn't really work on this one, and I assume that's button C there. So these two on the side. It took me quite a while. Like I thought about this, and I'm like, well, why does this not work? Why does this not work? By the way, this is the one that's not actually needed. This wire here. This is the output from. I think output number 3 or 4 on the 4017. If you're wondering why there's a dangling wire around, it's not actually needed. As you can see, looking back at here, this doesn't actually do anything. It's only the rising edge of pulse number 4 that matters. So this one doesn't actually matter. So the select is entirely handled just by looking at the first 2, and that's handled by looking at 4. But anyway, stop jumping all over the show. And I've disconnected these 2 things here because these 2 LEDs are actually going to be up and down, and not what they currently are. So hopefully left and right, all the way over here. So that's a bit awkward. But these are actually the counter ones for left and right. And if I plug them back in again, they'll always be on because they're outputting ground. Sorry, I'm gonna need a drink because it's that kind of weather. A drink of water, of course. So what's the problem with this? Well, actually the problem is the same old thing as usual, but I didn't actually think I needed to do this. I did think I needed to do it for the end result, but I didn't think I needed to do it when a controller is plugged in. And the thing that I'm talking about is that I need actually pull-up resistors to pull it to high in general. And I didn't think I needed it because the output that's coming from here is actually the output from this 74HC157 over on the controller, the Megadrive pretend controller over here. And so I didn't think the outputs would be floating, but for some reason they seem to be, and only this problem only seems to occur on the last pin, so I don't quite understand why that's happened. Like, I've gone through and I've looked at everything, and they're definitely plugged into the IC, and you'd think that IC can't have floating outputs. And like, I went through with the wires and I double checked all the wires, and then I had them like pulled to the ground and over here on the side and pulled high to specific values, and it does change these things. But it just seems like the output from here isn't actually being pulled either way. It's sort of floating when I don't understand why it should be. So I might have to go back and look at that. But the problem is actually quite easy to fix, which is simply, and I'm going to use a bunch of 10Ks to do this. The reason that you need them, of course, is that if you don't have a controller plugged in, then the inputs into this thing here will be floating because there's nothing on this. And then they'll just be all over the show, and then the lights will go. Funny, maybe we can actually set it if we unplug it. Yeah, that's what you see now, is they're all kind of randomly popping on and off. So if I go to put my finger near the thing, you'll see that it changes quite dramatically. So we're going to need 6 pulled up resistors at least in order to, so I'm pretty sure this is the inputs here, right? It's been actually like, a few days since I've actually done this video, so I've gone and completely forgotten what side is the input. So here is this thing, 74. This is the 574 ICs over here. So these are the inputs. So all I have to do to get this to work is, so when I put this in, everything, the LEDs should all go off. This is basically what should happen. It's going to be a bit tricky to get this done nicely. So many dangling wires all over the show. So anyway, we'll put that. So one of them should go out. And I actually thought at the time you only actually have to put in 4 pull-up resistors. Sorry, yeah, we're going to stick. They're pull-up resistors. We're not pulling down. So now it's all gone dark, but I can still get a couple to come on if I touch it. So hopefully I should be able to touch the end and not to have. I don't think I'm going to go with any static discharge problems. And it's plugged into the circuit. I'm going to have to go through a video about my understanding of the CMOS protection things against static electricity stuffy. But it's looking a bit of a mess. But the thing is, these wires are going. In fact, I changed the layout on the board slightly. So before I had wires from here jumping all the way across to here, and then the other 4 were jumping all the way across. I don't know. I had one set of wires coming from here going to there, and then another set of wires coming from here and going into this one. So there's 2 latches, if you remember from last time. But then I just put one set going into here, and then this set goes from that set over to this set, which makes somewhat neater. So we should have like no problems except for one. So I've done all 4. So I just figure that if I'm pulling one set up, I can pull the other set up, and that's fine, and that's not going to cause any problems. So now we shouldn't have any. So we had a couple of little incidences there, and nothing's happening now. I can't really make it come on. So those have worked fine. And now if I plug this back in, so the little light comes on, that's all working, and you should find that that one works, 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 that one works. So I did understand that I needed the pull-ups for the final result, but I am still confused as to why just one particular part of this didn't work, which is the pin number 9 on this thing here. So the start and select inputs, just they seem to be floating, so I'm not too sure why, but pulling it up definitely helped. So we do have to do one, we might as well just finish this off. So these two here are actually separate ones. Where we're going to put them, we'll have to put them over here. So these two have to be connected to the up and down. Again, they're going to have to be pulled up. So I might as well just do the pull-ups here. Except I can't pull them up, can I? No, they don't have to be pulled up because they're just directly coming off the and pulling it up is not going to be a very good idea. So what are we going to do? So up and down are pin number 1 and pin number 2, so that's not very far. In fact, I think we can just connect them straight across. Maybe we can. What happens if we connect them straight across? I'm not really thinking this through at this time of night. Maybe I could actually import them into, well, what happens now? Well, that actually works. So, which is what I guess they should. So yeah, there we go. So I've just connected them straight across. So now we've got those two working, and I don't know if you can tell, but there's actually, like, when I press that, it's straight away, and that one is a sort of slowy lag thing. And of course the obvious solution to this is to speed up the oscillations. So we'll just make our thing. So this is, I don't know, a very simple kind of machine device thing, and we can just speed up its clock rate, and then it should, I just got to find the right kind of screwdriver. It should be much more responsive. So is that's speeding it up? I think this is the right way to speed it up. So in the end, if I was going to make a proper version of this, it's not actually speeding up, is it? Maybe I have to go the other way. I feel like that would be very disappointing if this thing can't actually go any faster than this. It doesn't actually seem to change. How many times do you have to turn this round? That's going faster, isn't it? I think that's going faster. Alright, almost there. So the final thing, I'd actually use a proper 555 and fixed resistors. Alright, so that's going super fast. Look at that. You can barely even tell that it's flicking. We'll make it go full speed. Well, that's actually interesting. If it goes full speed, there won't be a problem with my one. So now it works super fast and reacts well. 1, 2, 3, 4, 5, 6, 7. It's a bit all over the show, but all the buttons seem to work, and everything seems to be individual. But it might not actually work on a 6-button one, because the trick with the 6-button one is that it reacts differently if you change the select from low to high fast enough. And by fast enough, it's basically like more than 60 times a second. I think it's related to that. It's related to the speed of the screen refresh kind of thing. It's in that ballpark, is what I'm saying. And this thing here is probably flickering a bit faster than 60 times per second. So it might not actually. You kind of want it to only work around like 25 times a second or something, just to be safe, so you don't have to worry about any sort of strange results from 6 buttons. But we don't have a, since I don't have a, what did I undo it for? Now I'm going to get confused as to which is which, so I don't have to undo the wires. We'll plug this thing in and we'll see what happens when it does it. It doesn't really matter about the 6-button part, because 6 buttons over here, of course, because there are more than 6 buttons if you count these things as buttons. It doesn't really matter on this one because it's absolutely stuffed, so I don't know what I did. Well, I do know what I did. I plugged it in wrong to my Arduino, and now it doesn't work. Which is why, if you haven't watched the previous videos, why I built my own little pretend controller, simply so that I can test these things and break this. If I make this one wrong, then I don't break these controllers, which are harder to replace. But that one, look, you press F, you get a bunch of, you get the same kind of pattern coming on. and it's a bit of a weird one, isn't it? Look, so you've got 3, if you hold that down then they all come on, and that looks really weird. That's really weird. And they all seem to do the same kind of things, nothing particularly different. But these ones don't seem to work. These ones actually give a result, which is kind of weird, and they give more LEDs. The last time I tried this, I'm pretty sure all the things came on, but maybe some of them, maybe because I hadn't put all the pull-up resistors. But you can see that this does not give the correct answers, and I'm sure it doesn't give the correct answers when you plug it into this thing. So when I can find the one that I had beforehand, the one that does actually work, we can test it again. I do have, where did I put it? I have another one here. This desk is a mess, so I can't find anything. I did have another kind of brand one of this. So there were two fake Sega machine things I have, and one of them has controllers with the same kind of plug, but it doesn't appear to react the same way. It doesn't appear to be wired up like a proper Megadrive controller. But the point is that stuff, this works as far as I can tell, and it's all done. So I'm going to make that up to a real project. And the one last thing is, I did actually get my PCBs in the mail today, but they've got quite a few little mistakes on them. Well, they've got 2 major mistakes, and I'm kind of annoyed. But it's all I'm blaming that fritzing software, because it got, at one point it just sort of stopped working, and then it was really hard to get it to do what I wanted. And so I had to kind of like mash it all together and get it to work. And I was just like, I don't care. I spent quite a while making up this PCB, and I just want it to work. But obviously I should have taken a rest and come back and had a look at it again and gone, oh wait a second, I haven't done this and I haven't done this. But it certainly makes me more enthusiastic to write my own software to do it, because I think I can do a good job. But right now I haven't got the time because I want to work on something else. But I'm going to probably start making my own circuit designing software, because that's the kind of stuff that I like to do. And I've got some ideas about how I want to do it. But next time I'm going to try and use the Eagle CAD, because I've got a book about how to use Eagle CAD. So I'll give that a go again, but I found that really horrible to use last time I tried. But I can show you, I don't actually know where I put the PCB now. It was around. I'm going to make it up and see if I can patch it up so that it works. But at the moment, there's a couple of problems that might be. There's going to be a few extra wires on the top. So anyway, thanks for watching, and we'll do something interesting. Well, actually, I've got lots of cool things to do. lots of cool things to do. So thanks for watching, and bye.